In this video, we'll discuss about laboratory quality control too. As we know that quality control is the statistical process, for that we need to understand some basic statistics for monitoring and evaluating the analytical process. Why we want to know statistics? For monitoring and evaluating the analytical process. So the specific learning object are here: mean, standard deviation, coefficient of variation and standard deviation index. So in this video we can learn about mean, standard deviation, coefficient of variation and standard deviation index. Previous video we discussed internal quality control and external quality control. Internal quality control uses two basic strategies. That is, one is mean, another one is standard deviation. While that external quality control, important thing is standard deviation index. Other important quality control statistics is coefficient of variation, CV. Coefficient of variation, it is also called as CV. What is mean? It is the calculated average of that value. So what is means? Calculated average of the values. And it is the laboratory best estimate of the analyte's true value for a specific level of control. Laboratory best estimate of that analyte's true value for a specific level of control, and it is calculating by using that formula epsilon xi minus n. So it is calculating by using this formula, where it is calculated by summation of individual value. So calculate using that formula, and where it is calculated by summation of individual values, summation of all the individual values, sum of all the individual value divided by number of individual value. So number of individual value means totally 1 2 3 4 5 6 7 individual value is 7, total number of value is 35. So divided by 35 divided by 7, 5 is the mean value. So let's calculate mean using the data set containing 7 numbers. Data set containing 7 numbers. These are the numbers. So we have to add all the number. So all the number we are adding means we have 35 divided by total numbers, that individual value 7. So we get 5 is the mean. Second is standard deviation. It is also called as SD. It is measure of how much the data varies around at the mean. So it is measure of how much the data varies around at the mean, and it is used to measure dispersion or scattering of a value around at the mean. Used to measure dispersion or scattering of a group of value around at the mean. It is the primary indicator of precision. It is a primary indicator of precision, and it is measure of random error plus or minus. It is used to measure random error plus or minus. So this standard deviation is calculated by using this formula, that square root of epsilon x minus x bar the whole square divided by n minus 1. So this x bar means average of that quality control value. Xn minus x bar the whole square, sum of square of difference between individual quality control value and the mean, the number of value in the set of data set, number of value n minus 1, n totally we know 7 number, 7 minus 1. So for that data set containing, these are the 7 number, we already find that mean 5. So how we can calculate it, how we can find out standard deviation? These are the given data. This one is the mean value. This is our formula. Here we want to square all the values. We want to square. Then divided by 6. Then we find out that root. We have that standard value. This is the method we can find out ST value. Given data, find mean. After that we want to, this one, that this 5 is the mean. After that this 5 is the given data, this 2 is number, this 5 is the mean. Like that we want to square that value. After that n minus 1 6, so we will take that square root, we get that value. So we have to subtract mean from all the value, that is 52399754, and then we will get the difference, and we have to square the difference, and we have to add the difference, and we have to divide it by 6, because we have number of value is 7, and this denominator, the formula we have n minus 1, that is 6. After that we have to find that square root, we have that value 2.3. So mean and standard deviation of control value are used to calculate the range of acceptability, that is plus or minus 3 standard deviation. So the two strategies are used to find out the range of an analytes, and if the standard deviation. How to calculate range? For example, if mean is 100, if mean is 100 and standard deviation is 2. How to calculate plus or minus 1 standard deviation? If you have to subtract minus 100 minus 2, so 98. After that you have to add with 2, plus or minus 2. Here we want to do minus 2, here we want to add plus 2. So subtract 2 from 100, you have add 2 from 100, 2 in 100. So you get that range 98 to 102, and 68% of data points will fall in that range. So plus or minus 1 standard deviation. 100 is mean, standard deviation is 2. So 100 minus 2, 98, 100 plus 2, 102. So here that percentage of data point is 68%. Then how to calculate plus or minus 2 standard deviation? Here 98 minus 2. Here 102 plus 2. So we get that value 96. Here 104. So lower range 96, higher one is 104. So in this one data point 95%. 4 from 100, add 4 in 100. So we get 96, 104. So you get that range 96 to 104, and 95% of control value. In this plus or minus 2 standard deviation, that is the range of 96 to 104, 95 percentage is the data point. Then third one is standard deviation, same only. We have multiply standard deviation by 3, so we get 6. So 6, okay, multiply standard deviation by 3, so we get 6. Here 100 minus 6, here 100 plus 6, so here 94, here 96. Add 6 in 100, then here subtract minus from 100, so 94 to 106. And 99.7 percentage of control value in this plus or minus 3 standard deviation. This is the normal. This one is the normal. So this one is the normal distribution curve plus standard deviation 1 2 3 minus standard deviation 1 2 3. So this one is the normal distribution curve. Any repeated measurement will yield degree of dispersion around that mean, that is standard deviation. Add this degree of dispersion varies as per the parameter measures, and in stable analytical system both the mean and standard deviation stays with the sudden a limit and fairly constant. That is why these properties is used to monitor the stability of analytical system. So we can say that if the analytical system is stable, 68 percentage of the time of our value will be within the standard deviation, 95 percentage of value within plus 2 standard deviation, plus or minus 2 standard deviation, then 99.7 percentage of value with 3D standard deviation. So this one is the 68. So here 68 percentage, 95 percentage, 99.7 percentage. Normal distribution curve is also called as Gaussian curve. So it is also called as Gaussian curve. What is Gaussian distribution? In this analytical space in a lab, normal distribution is exhibited by well-preserved biological material on repeated examination. So normal distribution is exhibited by well-preserved biological material on repeated examination. This properties is used to statistical quality control. And statistical quality control are used to verify the ongoing performance of analytical system. Statistical quality control are used to verify the ongoing performance of analytical system. The next strategies is coefficient of variations. CV is standard deviation expressed as a proportion of mean. This coefficient of variation percentage is equal to standard deviation divided by mean into 100. This coefficient of variation used to assess instrument, reagent and control product using that coefficient of variation. So this one used to assess instrument, reagent and control product using coefficient of variation. Let's see why that coefficient of variation is important. um, this one important to assess two analytical method. For example, there is two important method by which glucose can be estimated. One is hexokinase and another one is glucokinase method. First one is hexokinase, second one is glucokinase method. Standard deviation of hexokinase method is 4.8 and glucose oxidase peroxidase is 4. On comparing hexokinase method, glucose oxidase is the best method. For that you can calculate this coefficient of variation. For calculating that we required mean. So in the case of hexokinase method, mean is 120. For glucose oxidase peroxidase method is 100. For calculating we get this coefficient of variation 4. So looking at coefficient of variation, we come to know that both method are equally effective. Both are 4 only. So both are equally effective. So that coefficient of variation is important to compare that various method. It can also used to compare the instruments also. Standard deviation index SDI, x bar lab minus x bar group divided by x group. Standard deviation index is an indicator which we get the external agencies. So this one we get the in the external agencies. Yes, group external quality assessment scheme, and it is calculated by using our laboratory mean for the particular analytes and the mean of group. The group means the mean of various laboratory involved in that particular external quality assessment scheme and divided by standard deviation of that group. So if we have standard deviation of that particular analytes between 1.0 to between -1 to +1, our external quality control is excellent. So internal quality control program is excellent, and if that value is between +1 to +2, it is good. If it is +2 to +3, it is accepted. Our result accepted with cautions, and its warning signal for use. We have to troubleshoot our internal quality control programs. For any particular analytes, the standard deviation beyond +3 plus or -3, the performance of that particular analytes is unacceptable, and it is actual signal we have reject our all runs. We have to take correct measures marker to correct our internal quality control strategies. So this one we are using for external quality assessment scheme, external agencies. Here we can compare our result from external assessment scheme. Our result -1 to +1 means excellent, +1 to +2 means good, +2 to +3, this means caution, warning signal, but beyond 3, unacceptable. Okay. Thanks for watching.